When you look up at the night sky, it all seems so peaceful, right? Just these tiny, twinkling lights. But the lives of stars are unbelievably dramatic. And their final chapter? Well, it's one of the most violent, spectacular, and genuinely important events in the entire universe. So yeah, let's get into it. For billions and billions of years, stars are basically these colossal nuclear furnaces. And while they look so steady and calm from way over here on Earth, their whole existence is this incredibly high-stakes balancing act. And when that balance finally gets broken, their deaths are, well, they're even more spectacular than their lives. So what really happens when a star's light finally goes out? Does it just, quietly fade to black? Or is it a violent cosmic fireworks show? The wild thing is, the answer depends entirely on this epic battle that's been raging inside that star for its entire life.
See, to really get how a star dies, you first have to understand how it lives. And its entire life is defined by a massive cosmic tug-of-war between two absolutely titanic forces.
Okay, so deep inside every single star, there's this constant battle going on. On one side, you've got the relentless, crushing inward pull of gravity that's trying to squeeze the star down into the smallest possible point. But fighting back, you have the immense outward pressure from nuclear fusion happening in the core. It's like a controlled explosion that releases a staggering amount of energy. For billions of years, these two forces are locked in a perfect stalemate.
But here's the catch. That nuclear fuel isn't infinite. It can't last forever. Eventually, that furnace in the core starts to sputter out. The hydrogen runs low, then the helium. And when that happens, the outward push from fusion starts to fade, and that delicate balance is completely shattered. And gravity, which, by the way, never ever gets tired, finally starts to win. With nothing pushing back anymore, it takes over. And in a matter of seconds, it triggers the star's final, violent collapse. The great cosmic battle is officially over.
So the star collapses, but what happens next? Does it just fizzle out, or does it explode? Well, its entire destiny, its entire future, hinges on just one single thing: the mass of the core that's left behind.
Okay, so check out this chart. It shows you the different paths a dying star can take. As you can see, the lower mass stars, kind of like our own sun, they take a gentler route. They end up as a planetary nebula and then a white dwarf. But the really big, massive stars, whoa, they have a much more dramatic finale, ending in a supernova and then becoming either a neutron star or even a black hole. Let's start with the most common path first.
All right, destiny number 1. This is the most common fate, and it's the one waiting for our very own sun. For these smaller stars, the collapse is less of an explosion and more of a cosmic retirement. They become a strange object called a white dwarf.
So why does the collapse suddenly stop? It's thanks to this totally bizarre quantum rule called electron degeneracy pressure. It's a mouthful, I know. But basically, as gravity crushes the core, the electrons get squeezed so tightly together that they start pushing back. It's like a cosmic social distancing rule. They just refuse to be packed into the same space. And this pushback creates an incredibly powerful pressure that finally halts gravity, leaving behind the stable, super-dense object about the size of Earth, but with the mass of the sun.
But here's the thing. Even that quantum pushback has a limit. A brilliant astrophysicist named Chandrasekhar figured out the exact tipping point: 1.44 times the mass of our sun. If a star's leftover core is below this limit, it gets to retire as a stable white dwarf. But if it's more massive than that, well, the electron pressure gets overwhelmed, gravity takes over again, and things get a whole lot more violent.
So what happens when a more massive star dies? Or when a white dwarf crosses that 1.44 limit? The end is anything but gentle. Instead, you get one of the most powerful events in the entire universe: a supernova. A supernova is the colossal, mind-blowing explosion of a star. In this one cataclysmic blast, the star can briefly outshine its entire home galaxy. I mean, it's brighter than billions of other stars combined. And after this incredible light show, what's left behind is something even more extreme. What's left is a neutron star. During the collapse, the pressure is so intense that electrons and protons are literally crushed together to become neutrons. You're left with an object that's more massive than our sun, but squeezed into a sphere that's only a few miles across. The density is it's staggering. Get this, a single teaspoon of neutron star material would weigh billions of tons here on Earth.
But what if a star is so massive that not even the incredible pressure holding a neutron star together is enough? What if gravity just keeps winning?
For the absolute monsters of the cosmos, the most massive stars out there, gravity becomes truly, utterly unstoppable.
This is it. This is gravity's ultimate victory. The core collapses all the way down to a point of infinite density. It warps the very fabric of space-time so severely that it creates a region where nothing, and I mean nothing, not even light itself, can escape. A black hole is born.
Now, I know what you're thinking. Collapse, explosions, black holes. It all sounds pretty grim, right? Incredibly destructive. But here is the amazing paradox. The death of a star is actually one of the most important creative forces in the entire universe. This creative destruction can happen in two main ways. First, you've got your core collapse supernova. That's when a single huge star just runs out of fuel and collapses under its own weight. The other way is a thermal runaway supernova, which happens when a white dwarf is orbiting another star and steals too much material from it, pushing itself over that critical Chandrasekhar limit and triggering a massive explosion. Because inside that fiery explosion, a process called nucleosynthesis happens. The heat and pressure are so immense that they act like a cosmic forge, fusing atoms together to create all the heavier elements in the universe. We're talking carbon, oxygen, iron, even gold and uranium. The supernova then acts as a cosmic delivery service, blasting these new elements, these building blocks for life, all across the galaxy.
And this leads us to what is, for me, one of the most profound and beautiful ideas in all of science. It's the direct connection between these violent cosmic events and our own existence right here, right now.
The great science communicator Carl Sagan famously said, "We are made of star stuff." And the most amazing part about that quote is that he wasn't being poetic. He was being completely 100% scientifically literal. We are quite literally made of stars.
I mean, just think about the journey. A massive star lives for millions of years, dies in a spectacular explosion, and scatters all the elements it created across space. Those elements then drift for eons, eventually clumping together into clouds that form new stars and new planets, including our own. And eventually, those very same elements became a part of us.
So think about this for a second. The actual atoms that make you up have a cosmic history. The iron in your blood, the calcium in your bones, the oxygen you're breathing right now, every single one of those heavier atoms was cooked up inside a star that lived and died long, long before our solar system even existed.
It really makes you think, doesn't it? A star's death is a violent, definite end for that one star. But for the rest of the universe, it's the seed of creation. It's the engine that makes new planets, new life, and even us possible. So when we see a star die, are we really watching an ending, or are we just witnessing a brand new beginning?